So welcome back. I'd like to welcome you all to the second session of the day, first day, second session. The topic is brain, mind, and consciousness, the limits in mathematical modeling. Without any further ado, I would like to hand over the session to the session chair, Dr. Ramji Repaka. I'd like to, before welcoming him onto the dais, I'd like to give a brief biodata about him. I'd like to tell a few words about him. Dr. Ramji Repaka is an associate professor in the Department of Mechanical Engineering and Center for Biomedical Engineering at IIT Ropar. He received his bachelor's degree in mechanical engineering from Andhra University, master's degree in mechanical engineering from Jadavpur University, Kolkata, and PhD in mechanical engineering from IIT Kharagpur. He worked as assistant professor in the Department of Mechanical Engineering at NIT Rourkela before joining IIT Ropar. Dr. Ramji Repaka is also an associate editor for ASME Journal of Engineering and Science in Medical Diagnostics and Therapy. His research areas include heat transfer, applied thermal engineering, bioheat transfer, cancer diagnostic and therapy, biofluid mechanics, and refrigeration and air conditioning. So I would like the audience to welcome our session chair, Dr. Ramji Repaka. Sir, please take over the session.
So, thank you very much, Mr. Manas. So, welcome you all back to this session, the second session of this day. Basically, this session's name is Brain, Mind and Consciousness, Limits in Mathematical Modeling. So, in this, we are going to have an excellent presentation by Professor Sisir Roy. He is the first speaker, and then the second speaker is Sri Varun Agarwal from Bhaktivedanta Institute. So let me introduce Professor Sisir Roy before he is going to deliver his talk. So Professor Sisir Roy, he is a visiting professor and a senior Homi Baba Fellow at the National Institute of Advanced Studies, IISC Bangalore. So he has obtained his PhD in theoretical physics from Indian Statistical Institute, Kolkata in 1979. He has been a professor at the Indian Statistical Institute, Kolkata for 21 years and also a visiting professor at the University of Arkansas, USA and George Mason University, USA and visiting scientist at Henry Poincaré Institute, Paris. His areas of research include foundations of quantum mechanics, brain function modeling and cognitive science, data analysis and quasar astronomy. To his repute, he has more than 170 peer-reviewed papers in internationally renowned journals and 13 research monographs and edited volumes. So with this short introduction, I request Professor Sisir Roy to give his presentation. So Professor Roy, hand over to you. Thank you very much. I hope the voice is audible.
Hello.
Yes, Professor Roy, please.
Okay. Can you see my presentation?
Not yet, sir.
Not yet. Okay. Let me share it.
Share the screen.
Yeah. Yeah. Can you see it?
Yes, sir. Yes, sir. Please make it. Yeah.
Yeah.
F5.
Okay. Okay. Good afternoon, everybody. And the title of my topic is Noise, Coherence, and Meditation: Challenges to Modern Science. Before starting my lecture.
So sorry for the interruption. You can make it in the full presentation mode, sir. In the right side, bottom one. Yeah. Yes, yes. Thank you, sir. Thank you very much.
No, but I can, yeah, okay. So before starting my presentation, let me start with a preamble, like why I started this kind of presentation. You know, India has rich heritage of what we call science and philosophy. And many people believe that our ancient wisdom,
Sorry, sir, your presentation is not in full mode.
it is, but in my screen, it is in full mode.
Okay, sir, please continue.
Or you have the presentation with you. I have sent it already, that you can start, whichever you like. You like to do that, or let me continue?
Sir, you continue, sir.
Okay. So let me start again, that why I started to give this kind of topic before the young and some established scientists. Many of us who are doing hardcore science, we go to the conference and give our lectures of our own domain. That is fine. But now the questions are growing, are coming more and more from young scientists and young scholars and young students, that whether we can get some insights by investigating the ancient Indian traditions. Otherwise, why they will spend their time, valuable time to pursue it? This is a very, very big challenge. Not only that, even in technology, many people think that we had in our ancient times, we had knowledge of rich, different type of technology. But the problem is that we asked many people whether you can find the seed of any new technology which does not exist now, and we can say the students, researcher, and to the world, look, this is the technology we had, and now we can build up this new technology. But we didn't get satisfactory answer. So what we are trying to do, we tried to do, arrange some national or international workshop. It is interdisciplinary workshop. We invited many traditional scholars as well as hardcore scientists. And I have published 2 books on this kind of issue, whether there is any kind of convergence or divergence between ancient Indian wisdom and modern science. The first one I published with mathematician Professor Ralph Abraham from USA, called Demystifying the Akasha, Quantum Vacuum and Consciousness, 2011. Then in 2021, I have published one more book that is called Understanding Space, Time, Causality, Modern Physics and Ancient Indian Tradition, jointly with Professor B.V. Srikantan, who is no more now. And this lecture, in these 2 books, we tried to show that really whether we can get insights from our traditional wisdom to understand more the modern science.
Excuse me, sir. Sir, your slides are not running. I think.
Slides will run.
No, here we could not see any change in the slide movement.
Here,
so if you don't mind, can you just log out and then log in again, sir?
No, here these slides are not changing.
No.
No,
You
then
could only
why?
see the first slide.
Can you do from your side? No, okay, let me start it. Share again. Okay. Now, if I change the slide, can you see it?
Now it is.
Okay, so let me do it that way. So recently, a month before, we have published another mainly technical book published by Springer, published say in April 2022. The name is Noise and Randomness in Living Systems. But it's a completely technical book. But now why I am showing it now here, where we have a kind of intention, whether we can get insights from our traditional wisdom in understanding modern science, or to understand some of the issues in modern science, deep issues in modern science. If you look at this book, Noise and Randomness in Living Systems, it contains two parts, part 1 and part 2. Part 1 contains that noise and randomness plays a very vital role in science and engineering. This is well known. In communication channel, in TV channel, you are looking at the picture or you are receiving some telephone call. There will be a lot of disturbances. So this is noise. So motto is how to reduce these disturbances. And the second part, it is already well known that in case of physical systems, mainly in science and technology, we know what these disturbances or noise can create. But the whole paradigm changes. As soon as there is a phenomena called stochastic resonance has been discovered in nonlinear dynamics. I am going to tell you briefly what is stochastic resonance. And it gives us new vistas regarding the role of noise in the behavior, understanding the behavior of living organisms. So why I am telling this kind of things? Because if you look the chapter 13, in chapter 13, we tried to understand the role of noise and coherence in meditation or samadhi. This is one of the very debatable and interesting areas all over the world. People are trying to find the neuronal correlates of the brain. Brain consists of billions of nerve cells called neurons. Now, if some people sits for samadhi or meditation, I will tell you what is samadhi and what kind of samadhi is there in our traditional literature. So they are looking what is happening, or if something at all happens in our brain anatomical structure or neuronal architecture. And many results are coming almost every day in our country, true. And during these investigations, we found a very interesting thing, that in this kind of process, which we call samadhi, the noise plays a very important role. But then you can ask me, what do you mean by noise? Well, that's a good question. I'm going to respond it. So my plan of my talk is simply can be divided into several groups. What is noise? In general, in physical systems, as well as in biological systems. Then why we try to understand it? Why you are spending time to understand what is noise? Then we'll go to what is called samadhi, or in English, meditation. What are the different type of meditation or different stages of meditation? What are the limitations? What are the limitations and challenges in meditation research? And then, is it possible to characterize the various states of samadhi or meditation with the help of the knowledge of modern science? No. Yeah, thank you. It's working now. Now, you can ask me, what is noise? In any physical system, the fundamental fact is that when the signal voltage arrives, the demodulator, it will be accompanied by a voltage waveform, which simply varies with time in an unpredictable manner. And this unpredictable voltage waveform constitutes a random process, usually known as noise. Here the signal plays destructive, here the noise plays destructive roles, since it corrupts the signal. Because we will try to understand how to minimize or how to maximize the signal to noise ratio to minimize noise. Then the question comes, why do we need to understand noise? What is the necessity of that? Noise is often a limiting factor for the performance of any physical device, like electronic device or telecommunication systems. So for better performance, we need to understand how noise limits the performance of the system. Now, it is well known to the student of uh, engineering and science that how to represent a noise. We can represent a noise. I'm not going into details. I'm going to say that we use a term, we construct a term called spectral density, spectral function. The spectral density has been shown to be 1 by f to the power gamma, where f is the frequency and gamma lies, if gamma is 0, it is called white noise. If gamma is 1, this is pink noise. Oh, what happened again? And if gamma is 2, called red noise. What are the types of noise? Types of noise is thermal or Johnson noise, short noise, or simply called 1 by f noise, called flicker or pink noise. Then we can calculate what is the average noise power. For any periodic voltage signal Vt across a load RL, the most of you know in your textbook, then we can calculate P average. And then you can calculate the spectral density. Omega is the frequency. Spectral density can be calculated in terms of the correlation functions, autocorrelation and cross correlations. Now we can have a visual look. If we compare different types of noise, like say here, this is white noise. As I told you, gamma is 0 and its correlation function is delta function. And now this is, if gamma is 1, 1 by f to the power gamma, then, or if it is f to the power gamma, then gamma is -1, then we can say this is pink noise and its spectral density is like this. Then if gamma is -2 or 1 by f to the power gamma is 2, then this is the spectral density of red noise. I am telling this simply because to make it acquainted with the types of noise we live in different systems in science and technology. Now, this is a beautiful picture by famous painter, Sisir. So this is the original painting, and this is filled with noise. You can clean the noise with filter or any other lot of devices. So this picture, it is full of noise. If you clean the noise, you can get this clear picture. This is one of the examples how we can deal with the noise. Then the discovery of stochastic resonance. So this is a remarkable or pioneering discovery in the field of nonlinear dynamics. It says that stochastic resonance is a phenomenon in nonlinear system where introduction of noise enhances the detection of sub-threshold signal. So what is the importance of this? Stochastic resonance says that the noise can enhance the signal detection of the sub-threshold signal. So here noise played a constructive role because we have seen already that in many system, electronic device, communication channel, or like painting, we have different kind of noise which plays destructive role, and we can reduce that noise to get the more and more signals. But here, stochastic resonance is a phenomena where it says that even noise plays a constructive role. And that is very important in understanding the functioning of the biological systems. So the stochastic resonance, it can have a great role in sensory biology. Noise enhanced phase synchronization occur in case of array of non-identical noisy oscillator. This is already known. For example, in the case of cardiorespiratory synchronization. But the issue is, which has not resolved, is the following: whether stochastic resonance at the level of single ion channel or for an ensemble of channels. So you can ask me, what do you mean by ion channel? What are the function of it? Ion channel, I'll show you at the last, the structure of the ion channel. Ion channels are the pores in the protein membrane, which plays very important role in information processing of the brain. There are many types of ion channel: potassium ion channel, sodium ion channel, calcium ion channel. So depending on which ions can pass through this channel, and we call them that kind of channel. Like if potassium passes through that kind of pores, we say potassium ion channel. If sodium passes through that kind of channel, we say called sodium ion channel, etc. Now the issue is that because if you consider the ion channel, there are two gates at the two end of the tube at the nanoscale. Now, when tube opens, gate opens, then ions are entering into the channel, then gate closes. After that, the other gates will open and the ions will be coming out. In this way, the whole process is going on. So, from the experimental findings, the people found that the opening and closing of the gates of this channel makes a random process, which means it creates a lot of noise. Now, this noise, when the stochastic resonance occurs at the level of single ion channel, why single ion channel? Because every cell, every neuron contains thousands and thousands of channels. And there are billions of ion channels all over the neuronal anatomy. So the issue is whether this type of phenomena, which enhances the signal detection, occurs at the level of single ion channel or at the ensemble of channels. Then question comes whether stochastic resonance is exploited by central nervous systems and brain as a part of neural code. Answer is yes. I'm not going into details because this is very, very beautiful and long story. Now you can ask me, now we are slowly going the noise in biological system. Then we'll go to samadhi, how noise plays important role and in which way our scriptures or different texts gives rise to this kind of conceptual structure. So what is the meaning of noise in biological system? In biological system, noise refers to variability. Variability in which sense? Variability in behavior, variability at neuronal level, variability at the gene expression, because it is found that even for the genes which are identical and which have identical history, but even their expression differs. So how it happens? Scientists, they discovered that inside the gene, there are biochemical reactions which is random in nature. This is, they call it internal noise. So because of the existence of internal noise within the gene, it gives rise to variability of the expression. So one is internal noise, another is external noise from the outside world. And I have now you can ask me that I am mainly focused to tell about the story noise in meditation. You can ask me, what is meant by noise in meditation? I have a small video, but I don't know whether I'll be able to run the video. Maybe the organizer, I have sent the video to organizer. If they run it, is okay, or I can tell you what is there. Can you do it? No, okay. So this is a video of famous Pandit or Swamiji of Kashmiri Shaivism. His name is Swami Lakshmanju. Lakshmanju was showing clearly a very interesting thing. He was not talking about noise, but what we can say that this is nothing but noise. He was saying that let us chant Om Namah Shivaya, Om Namah Shivaya, Om Namah Shivaya, Om Namah Shivaya. Oh, I have to go to the post office. Om Namah Shivaya, Om Namah Shivaya, Om Namah Shivaya. So this kind of scattered thoughts come during our meditation practices. So these scattered thoughts are nothing but, in our terminology, is noise. Because when we focus our attention to a particular object in the process of meditation, always a lot of scattered thoughts will come. And slowly, we have to reduce these scattered thoughts to have more and more focused attention. And these scattered thoughts are nothing but what is called noise. Sage Patanjali, in his Yoga Sutra, the famous text, they have one part called Samadhi Pada, which deals with meditations. In Samadhi Pada, in Yoga Sutra starts with Yogo Chitta Vritti Nirodho. So, Chitta Vritti Nirodho, what it means controlling of the, or stopping of the disturbances of the mind. And then we can start meditation. So here, controlling or stopping of the disturbances of the mind is nothing but controlling the noise itself. But you can ask me what type of noise it is, from where it is coming, even without chanting also. If you just close your eyes and meditate on certain object, this kind of thoughts, scattered thoughts will come. We will tell you that from where this kind of disturbances or noise is coming and how you can control it. So before that, if you look, thousands and thousands scientists are involved, scientists, neuroscientists, and psychoanalysts. They are involved in understanding what is happening in the brain during meditation. Yes, what they are doing, they are looking for subjects. Subjects means the meditator who are called deep meditator. Now you can ask me, what do you mean by deep meditator? I'll tell you just a few minutes after. So they invite deep meditator and untrained meditator who did not do practice any day in his or her lifetime. So they place them under the scanner. Scanner is imaging instrument, say EEG, fMRI, MEG, this kind of recording instruments. They get the image of the brain, what is going on when somebody is meditating. And what they're trying to find that, the brain contains different type of waves depending on the frequency. Say gamma wave, which is the higher frequencies, 30 hertz to 100 hertz, then alpha wave, beta wave, delta wave, etc. So these are coherent oscillations in the brain. And scientists are looking that how the coherence, what is the degree of coherence of these kind of oscillations happens during samadhi or meditation. There is a problem here. I will tell you the problem and what are the challenges here. Before that, let us look at the ancient Indian text, what they say. We are consulting three main texts, three main sources. One is Yoga Sutra Patanjali, Samadhi Pada, then Bhavanakram, written by Kamal Shila, a Buddhist scholar in 740 AD. Bhavana means meditation, krama is sequence. So states of meditation. Then a Jain scholar in 11th century, his name is Subhachandra, he has written a text called Ganarnava. So we are looking whether we can get some insights regarding the various states and the coherence from our traditional text. So these are the texts we are looking for. Now, you can ask me what are the states of samadhi, main states of samadhi or meditation. Two main categories. One is sampragnata samadhi, another is asampragnata samadhi. What is sampragnata samadhi? Sampragnata samadhi is that which is accompanied by reasoning, reflection, ecstasy, and pure eye sense. Asampragnata samadhi, when all the vrittis in the mind field are stopped. Only samskaras of nirodho remain as a residue in asampragnata samadhi. Again, you can ask me, what are the vrittis? So, in general, there are 5 types of vrittis: valid cognition, wrong cognition, imaginary cognition, sleep and memory, and asampragnata, also known as acognitive samadhi. Here lies the problem. We are trying to understand the text. In some text, no, in all the text, they said, then in all types of sampragnata samadhi, because sampragnata samadhi has again sub-states. I will tell you after 1 or 2 minutes, there are various states within sampragnata samadhi. They say that in sampragnata samadhi, the various states which they experience during meditation are related to cognitive activities. But in asampragnata samadhi, there lies a debate. People, even Jagasutra Patanjali, some interpretation is there or some commentary that is acognitive samadhi. We are looking for traditional scholars and their interpretation, because some other people say, no, it is also connected with the cognitive state. Let me give you one example. Ramakrishna Paramahansa, he told once that one day a doll made of salt is going to measure the depth of the ocean. So the doll enters into the ocean and then it melted away. So it cannot, how it can cognize anything? In that sense, it may be asampragnata samadhi and a cognitive state. Why I am emphasizing cognitive and a cognitive state, I will tell you when we try to use the modeling or different tools by which we can characterize the various states of meditations. Yeah, as I told you that during meditation, people like to find whether there is any neuronal changes. Yes, it is found that there are a lot of changes at the neuronal level when people are meditating. But we need to understand through our scientific knowledge. And there are, before that, we need to, let me tell you before that, as I told you, that sampragnata samadhi has again mainly 4 levels. Savitarka samadhi, savichara samadhi, sananda samadhi, and sasmita samadhi. So in these states, people think that they are related to cognitive activities. How do you know these cognitive activities? Because people try to understand what is the neuronal correlates or what is happening in the brain or neuronal architecture with the imaging technique. And they found that there is dominance of some kind of oscillations, say where alpha dominates, where beta dominates, where gamma dominates, but in particular cortical areas. So these cortical areas are again related to different type of cognitive activity. Okay, this is fine, but now we are going to different problem. Now, the major limitation of meditation research is one, as I told you, people take deep meditator. What is the definition of deep meditator? The usual definition they take who performed 10,000 hours of meditation in his or her lifetime. Fine, but the question is deeper. Question is, consider case of Shankaracharya. Shankaracharya at the age of 5, he got enlightened. So obviously, he did not do 10,000 hours of meditation practices. So I think we need to understand in a deeper way how to say that this person is a deeper meditator, that person is not deeper meditator. This is not really issue resolved. This is one of the challenging issues, whether scientifically we can resolve this issue. Another, we met many gurus, present gurus, and we talk to them regarding use of various meditative techniques. Some people use vipassana technique, some people sahaja, etc. And we asked that, well, can you practice? Say you practice 5 years and vipassana and you think that, okay, you have achieved something. Then you go to other kind of techniques. They told, no. But look at Ramakrishna. He told that he tried every path, but reached to the same state. So this is another challenging issue, to find the subjects which had this kind of experiences. What happens if he practices one technique, then he goes to another technique? And we want to look what happens to his or her neuronal level. Now, you can ask me, well, in our text, traditional wisdom, they say that there exist various levels of samadhi or various levels of meditation. Scientifically, how can we characterize so that we can say, well, he has reached to the higher state and some other body he has not reached to that kind of state? There are many parameters people are using, but we will focus one parameter called coherence, degree of coherence. What is meant by coherence? Coherence in general, if you take, say, a group of neurons in a particular cortical area and another group of neurons, another cortical area, and if you try to find what is the phase difference between the two groups of neurons. And in optics, it is well known that interference pattern will vanish for particular type of angle difference of phase difference. In that sense, it is very well-defined concept. Degree of coherence, it lies between 0 and 1. If it is 0, we say, well, there is almost no coherence. If it is 1, we say he or she has reached to a very high level of coherence. And there are two types of coherence, spatial and temporal coherence. In nowadays machine, EEG, modern EEG machine, they have, most of the scientists, I can tell you frankly, the neuroscientists who are working in this field, they don't have any clear idea about coherence, degree of coherence, how it is related to noise. This is not their fault because of the training, the subject which they are studying, the way they are studying. We say that this degree of coherence, one is spatial, and this spatial coherence is already inbuilt in the program of EEG machine. So what people do, they take the subject, put under the EEG machine, and machine will say, well, his or her degree of coherence is 0.5, 0.6, 0.7, or 0.3, like that. But we say that to understand the states of meditation, you need to introduce also temporal coherence. This program, modern day programming, does not include that. So if we can include the formula of temporal coherence in machine like EEG, MEG, or fMRI, then it is possible to characterize even the various states of meditation, because meditation is not only a state, but it also is a process. So who are interested, they can look into mathematical formula of this temporal and spatial coherence. Here you see the degree of temporal coherence. Lies between 0 and 1. This is very well known in optics. Now, this is also true for spatial coherence. Okay. Now, another major issue. Well, we say that because the states, in our ancient text, it says that if somebody reaches to a particular state, he or she in the beginning cannot stay on that state for a long time. They will come back again to the original one. In that way, it needs more and more practice to reach to the different states. And they say also that when particular subject reaches to particular state, it forgets about the old samskaras before that. In that way, he is becoming more and more enlightened. But this is fine. How scientifically we can do or characterize this? For that, we need to have kind of tools to analyze the called noise analysis, or from EEG data. We have lots of EEG data, even in India, from different type of meditation. But noise analysis is one of the big issues. Why? Firstly, the source of noise in the brain there are various sources of noise. One, I told you that ion channels, potassium, sodium, calcium, etc. The opening and closing of the gates produces a kind of noise which disturbs our cognitive functions. So one of the major sources is ion channel, then synaptic noise. So there are two types of noise. One, when one tries to sit for meditation, one from outside, maybe from postures also, and one internal from the physiological functioning. And even within physiological functioning, there are different sources. Now, for scientists, we need to analyze the data and try to find out which kind of noise it is. In EEG machine, modern EEG machine, they have some kind of programs by which they can eliminate most of the external noise from outside. But it is not yet possible to analyze the data and find what are the internal noises. Well, if we can find out, this will be a big area of brain research, because very recently, people are trying to deciphering the noise in the brain. Yeah, this is a source of noise, as I am telling you. Then, this is the picture of the ion channel I told you. And this is, like a pores in the protein membrane. So, I cannot show you something else, but can you think meditation, objective of meditation to reach Kaivalya? That is true. But up to certain stage, meditation also acts as a raw noise regulatory process. So in each state, different type of noise will come. Whether that noise acts like enhancing the signal or it will distract anything. Now, one of my students, she asked me, very interesting. Okay, through meditation, we are step by step regulating the noise. So, signal is enhancing. What do we mean by signal? When noise will be very much limited, or we'll finish the noise, we'll eliminate the noise. Maybe pure consciousness. Pure consciousness in the sense that there are two concepts you have to be careful: context and content. If the pure consciousness is placed in the context, then you have cognitive activity. If there is no context, then it's called pure consciousness. Maybe there is no such noise from physiological or outside. So, for scientists, the big issue is how to characterize the states of meditation, like using the coherence concept and degree of spatial and temporal coherence, and kill the issue, what is meant by deep meditator. Second, whether we can find, in the process, we can find a Pandora, we can open up Pandora's box, what type of noises are there in the brain, how they affect the different type of cognitive processes, etc. So both ways, it will be very, very challenging to neuroscientists, physicists, and computer scientists. Thank you.
So thank you, sir, for your wonderful talk on noise, coherence, and states of meditation. So now the dais is open for a couple of questions from the audience. Yeah, please. So can you give the mic? Ritvik? So a couple of questions from audience, sir.
Yeah, okay.
Yeah. The gentleman.
Go ahead, please.
Hello. Good afternoon, sir. You talked about meditation as noise regulatory process.
Yes.
Can you just elaborate upon this topic? I mean, this meditation only regulates the noise, or it reduces the noise, or it can increase the noise also?
No, as I told you, objective of meditation is to reach a Kaivalya state, not reducing the noise. But in this process, meditation is a process. In this process, noises are also being reduced. Noises in the sense of unwanted variation, like scattered thoughts. They are called noise. And they are not only reduced, maybe in the state of Kaivalya, in Asampragnata Samadhi, there is no noise.
I mean, if it regulates, then how can we quantify it? I mean, if it can be reduced, so we can measure it, whether the noise is reduced or it increases the noise. How can it be quantified that it is regulated or not?
Yes, this is a good question, and this is scientific. You need scientific background. Say, when you define coherence in physics, it is related with noise. So if you estimate the degree of coherence, I can tell this is the noise. I can also estimate the noise and type of noise, one by F noise, or white noise, or red noise, any type of. Because brain has a hierarchical structure of noises, a different hierarchy, different type of noise exists. Okay, so.
Any more questions?
Good afternoon, sir. Do you hear me?
Yeah. Okay, please go ahead.
Yeah. How can I think of reducing noise of some other person?
Yeah. I mean, two ways it can be done.
So let's say I have some noise in my mind. How you can control the noise in my mind?
I told you that even it is found, it's a good question, it is found experimentally that during attention to a particular object, it reduces kind of disturbances. It is neurobiological experiments, it says like that. But we need more and more neurobiological experiments to have a clear notion.
Okay, thank you.
So any more questions to the speaker? Yeah, Niket.
Hello?
Yes, sir. One more question from the audience.
Yeah, okay.
Yes, sir. Good afternoon, sir. So my question regarding noise. You told that there are two categories, internal and external noise. But basically, noise definition is that it is unwanted signal. And on the other hand, you are saying that internal noise is helping in improving our quality of life by balancing the neurohormones. So
Yes.
is it correct to say it is a noise, because noise is basically unwanted signal in definition wise? So this is the first question. And second question is like, can you explain how noise vibrations through japa kirtana and spiritual domain help? What type of internal noise it generates? What frequency and
Yeah,
all?
yeah. This is good questions.
Thank
When we say like uh, unwanted variation, it has a deeper, and it should have a deeper understanding. Unwanted in a particular context. Say somebody is very fond of Carnataki classical music. Now you play a very good Hindustani classical music or Western classical music. To her or him, it's noise. So it very much depends on the context. And the second one is more difficult question. As I told you, that to distinguish various type of noises from the data, like EEG data, is not yet done. We have to do it, and we have to understand from what sources internally it is coming, and in which way the stochastic resonance occur for this kind of noise. This is not yet done. This is the challenging issues. I am telling you challenging issues. Okay, any other question?
So any more? So otherwise, we can conclude this talk, sir. Sir, thank you very much for your excellent talk and creating awareness among the participants about this aspect. Thank you, sir. Thank you once again.
Okay, thank you.
Now we have the next session is scheduled, which is overview of foundation of science, issues, developments, and lessons learned. So this is going to be delivered by Shri Varun Agarwal, Director, Bhaktivedanta Institute, Kolkata. So before inviting him to talk, just I would like to introduce him about him. So Varun Agarwal is an alumnus of IIT Kanpur, Aerospace Engineering, and is currently the Director of the Bhaktivedanta Institute, Kolkata. He was a recipient of IIT Kanpur Director's Gold Medal in 1999 for his excellent undergraduate academic record. His research interests include the foundations of science and its possible connections with spirituality. His research for a deeper meaning of life culminated in meeting and taking personal guidance from Dr. T.D. Singh, which completely changed his life, after which he dedicated himself to the cause of selflessly helping humanity. He is the editor of many publications on science and spirituality, including Bhaktivedanta Institute's reputed annual science spirituality journal, Savijnanam, Scientific Exploration for a Spiritual Paradigm. His deep interest in the foundations of mathematics and the nature of consciousness and its relation to the nature of reality, as well as ancient Indian texts, has led him to interact and meet with renowned scholars at Harvard, Princeton, ETH, Stanford, and MIT. He has given numerous talks worldwide on the foundations of science, as well as on the foundations of life, mathematics, and spirituality. So with this brief introduction, I request Shri Varun Agarwal ji to take over the dais. Thank you very much.
I'll start with a short invocation. Om Jnana Timrandasya Jnanam Jana Shalakaya चक्षुन्मिलितं येन तस्मै श्रीगुरवे नमः। तस्मै श्रीगुरवे नमः। तस्मै श्रीगुरवे नमः। So, thank you, Dr. Ramji Rapeka, for sharing our session and guiding us through this journey. My sound is clear, audible? Yeah, okay, good. So, I'll try to go into the foundations, a short overview, a brief overview of this. So, before I begin, what I will do, I will show you few 20 unknowns or mysteries. They are not all, there are not so many, but 20 I picked up and quickly go through, and then we get into the topic. Okay, so next slide. Somebody is handling our PPT. Yeah, next slide. Okay. So this is Dr. Singh. You know him by now. He is the founder and of this institution, and we learned everything from him. Next. Okay, so the first, I will introduce you 20 unknowns or major mysteries today we have. So our Professor Haridas ended his talk with the time. What is time? So time is a mystery. Next. Your PPT should be a little faster for next 20 slides. Then we'll go slow. Okay. So what is space? This is a mystery. This space is a mystery from last 400 years. Whether 3-dimensional, 5-dimensional, 11-dimension, and in mathematics we talk about infinite space dimension. So, and you know, it is not an ordinary thing. Mind it. All our scientific theories today are based on some conception of a space. If your space is not clear, that theory breaks down in certain domain. Like that's how Newton mechanics works in domain with space as a background. When you change space, things. So space is still a mystery. Around the world, still conferences are held on a space. Next, matter is a mystery. So we try to fathom what is this matter, the particles, the electrons. Every day we have a new particle discovered. Is a mystery. Next, electron is a mystery, because if you see the history of understanding what electron is starting from particle to wave. We will go into it in the foundations. We will go a little bit, just trying to introduce you some of the unknowns. Next, man, the biggest mystery, you and me, more than the electron. Man is the biggest mystery. Next, how it all originated. The question of origins are a big mystery. Means whether is the origin of life, origin of whatever origins you talk about, origin of life is a big issue. We had a summer school last year on origin of life, origin of information, symmetry. You can talk so many origins. Next, what is life? Life is the biggest, one of the biggest mystery. This question comes, we will touch upon it later. Next, universe. Of course, we have a mystery in front of our eyes, the boundaries, the end, the age. Tremendous issues comes when you get inside the cosmology, the universe. Next, consciousness is a mystery. So what it is, especially last 50 years, this interest has grown a lot. Next, imaginary numbers is a mystery, because they are good numbers, they work well. We have in quantum physics, in Schrodinger wave equation also it comes, but then we don't have anything physical to that counterpart in this world. What they are, like Penrose was mentioning recently many times, that what exactly they are, we don't have anything in this world. It's just a concept, but it works. It's a mystery. Next, Language, origin of language is a mystery. Means there are scholars, is a deep topic. Sometime we will have some big workshop on this origin of language. Next, memory is a mystery. Means the way we use our memory, from where it originates. Some part is stored in the physical structure in neurons, some part somewhere we have memories of other. This is a huge area. Another mystery. Next, perception is a mystery. I talk to you, you talk to me, we talk each other so nicely, easily, but this conversation between two human beings is a mystery. We have a Nobel laureate, Stephen Chu in Stanford. He works on this ear and nose. Means when you understand how we communicate, we don't know actually. We try to understand if 5% of it through some physics, but we have no idea. Next, infinity is a mystery. We had a conference in IIT Bhubaneswar, mathematics and reality. So infinity is one big topic. You can talk about infinity in physics. You can has a different names, singularity in mathematics, everywhere this comes, but we use it, we don't know what it is. Next, creativity. Creativity is a mystery. We had our one of the essay competition on creativity this year. So some part of creativity we understand. We try to incubate. So many theories are there, but the core of creativity, where really the new idea originates, we have no idea. It is a mystery. Next, symmetry. Symmetry is a very simple term, as well as mathematical term, as well as now in physics term. So symmetry is a very beautiful thing which we talk about, but the mystery still is symmetry is a mystery, because how the universe has a symmetry in many aspects which we see. Next, the beauty. Beauty is a mystery. The beauty, like Einstein, scholars, they always search for a beauty in the equations, beauty in the nature, beauty in the laws of physics which we govern. So we see the beauty and we search for it. But then how come there is a even idea of beauty in this universe is a mystery. Next, free will is a mystery. I have some free will. I can go right now here, there, not absolute free will, but some free will I have. Everybody feels that we have some free will. At least all of us has freedom to will, if not action. So, but is a mystery. We have a book, Oxford Handbook of Free Will. Scholars, they always debate on it. Next, psi, we will touch upon it. Wave function. What is actually the meaning of wave function is still a mystery after 100 years. So I touched upon you 20 some of the unknowns mystery. Of course, is an unlimited ocean. Just to give you idea that if you go in the roots, is tremendous unknowns and mysteries. Next. So I enter now into the presentation. So we have a two kind of life, or two worldview we live in. Or one professor was saying, what is his name? He was is physics Nobel person. He was saying we have a kind of day science and night science. Means on when you are in a lab or when you are in a class, physics class, you talk about electrons, protons and quarks, right? When you are at home and with your parents and children, you talk about soul, God and all those things. So whether they both are there, both are consistent, or one of them is wrong, or both exist. So it's like a professor versus the home. That means the kind of reality we live in today. Next. So this is not a problem only for our home or two worldview. The founding father of quantum physics, Schrodinger, whose equation we use, Schrodinger wave equation, there is a beautiful quote by him. Is a strange reality. Dear reader, or better still, dear lady reader, recall the bright, joyful eyes with which your child beams upon you when you bring him a new toy. And then let the physicist tell you, in reality, nothing emerges from these eyes. Only objectively detectable function, continually to be hit by or receive light quanta. In reality, a strange reality. Means, as a physicist, I can understand that the phenomena, how the light is falling on his retina, and how, to some extent, that as a quantum particle is being shared, then understood, means reflected, all those things. But this explanation still doesn't seem to explain complete reality. Something, that's why I say last line, something seems to be missing in this explanation. So next. So another side, we have a big problem about a question which I showed you earlier. What is life? This question is not a biology only question. Physicist Schrodinger asks this question, this famous monograph, what is life? And this question comes again and again in our journals. In science journal, one of the 125 unanswered questions, what is life? So this is a next. Like one physicist put this question in this way. This is Paul Davis from Australia. That he put the question about life in simple way. If I have a bird here and it's sitting on a tree with this axis XYZ, you can decide, put it 0 there, t equal to 0, initial velocity is 0, and I can understand the system, this bird, whatever I can I really predict the system after a certain time, say t equal to t1 or 5 seconds, whatever. So we know that bird can be anywhere after 5 seconds. It could be here, it could be there. We have no way to really predict it. So Paul asked this question that, well, as a bird, I can see it, analyze it, cut it, and see each and everything, integrate the parts, whatever. But what there is in the bird, which the free will, which we call, that it doesn't come under our grip of our equations. So that's kind of question Paul Davis asks. It's an open question even today, valid for all life. So this side, this question is there. Next. So in the physics, from the time of in the modern physics, from Newton, Galileo, all of us, we trying hard to search for reality, right? All of them. We in our institute, we have been undergoing this foundations of science in physics, our internal symposiums. So we are undergoing their works of mostly the founders, what they are, especially their own papers and books. So very profound, each and every person works. Means if required, I will tell you some of the books by each person. I will show you later. Next. So the history, I will go a little bit touch into the foundations of modern physics. This whole physics, our idea of understanding nature, actually modern physics has started from that idea that from time of Newtonian mechanics, that you mathematize a phenomena. That's called Principia Mathematica, right? The math principles of mathematics. So you observe any phenomena in nature, model it, mathematize it, put in the form of today's differential equations, solve it, and try to explain the phenomena. Well, that works very well, certainly, but we face certain issues later. Next. So when we delve, as many of you have already got hint in previous presentations, when we went deeper into the physics in the subatomic world, we found that things are not same as we expected earlier. This is a Heisenberg. It is in quantum theory that the most fundamental changes with respect to the concept of reality have taken place. So one of the interesting thing, let me share with you, is that if one is really serious about foundations of physics, foundations of quantum physics especially, I suggest that reading the books by the founders themselves, Heisenberg, Schrodinger, Max Planck, Max Born. So what we used to do in our institution is that we used to go into the works directly into the founders, not by secondary authors. So secondary authors do give you a good idea, we appreciate their works. But if you go to the founders, you will get really to the root issues. Especially, I will refer most of the two people, Heisenberg and Schrodinger. Next. So the history of physics, quantum physics, as you know, started with light. It started from light, came to atoms, and then came to life. Issue of what is life. Next. So we know that we discovered that light not only has a wave nature, it has a particle nature, the famous photoelectric effect. Next. Parallelly, there were issues in atom, not going into details, you can get into it later. Next. Next thing came is de Broglie's wave equation. I will tell you next. That not only the light behaves as a particle and wave both, every material particle also has a wave associated with it, which you define by lambda h by p, right? So de Broglie was very shocked with this. When we read the book by Broglie, de Broglie was very shocked with it, that what does it mean that every material particle has a wave associated with it. Then that's why. Suddenly in the summer of 1923, I had the idea that coexistence of waves and particles, which Einstein has discovered in light, might be equally true for all particles of matter. So wave associated matter, what does that mean? That if you see the writings of de Broglie, these are a big issue. Next. So there, so if you see the history, the electrons, the understanding of electron, it has grown and grown. We started from particle, then we moved to wave, and then eventually found it's not just a normal wave, it is a wave function. So Heisenberg mentions in the book, there's a book by Heisenberg, very beautiful book, which we all can read who are interested in foundation physics and philosophy. Very good book. And foundation philosophical problems of quantum mechanics. These two books are very good by Heisenberg. So Heisenberg mentioned it was not a three-dimensional wave like elastic or radio waves, but a wave in many dimensional configuration space, and therefore a rather abstract mathematical quantity. Next. Yeah, this parallelly the uncertainty. You know that we had a big volumes of discussions of Niels Bohr and Heisenberg. Many of you might have heard and read in our library. At that time in IIT Kanpur, we used to have. So we used to read those conversations. Very beautiful. Means they were really shocked that why nature is putting such a limit of h cross on our exploration. It's a pure mathematical result, independent of any technology. Next. So this wave function is a mystery. Actually, if you see the Schrodinger works, we were going through it. So when they used to go for a picnic, Schrodinger and his friend, one time it is mentioned in one of the papers, Schrodinger, that his friends used to joke with him. Well, this is a poem they wrote in one of the picnic about Schrodinger's psi. Erwin Schrodinger with his psi can do calculations quite a few, but one thing has not been seen, just what does psi really mean. This is his friends was writing to him about psi, because this wave function, so many of the scholars have interpreted it, means it's kind of possibility waves, means different possibilities are there. Well, it's an open question. Next. So then, as I think morning our many of us scholars talked, Professor Das also talked, the measurement issue, which is one of the major issue in quantum mechanics, kind of a heart of quantum physics, that what really these two states, unless you open the box, the famous Schrodinger's cat paradox, that you have a geyser counter and you have couple of uranium atoms. This thought experiment by Schrodinger, he thought that let us have this experiment. So we have couple of uranium atoms, for example, and then we have a beaker and a hammer. Beaker has a milk with poison, and there's a cat there inside, and you have a box closed. So you don't know uranium atoms, if there are a couple of 2 or 3, you don't know. Half-life period will not tell you exactly if out of 2, one will die, one will finish or not. It's like a statistical result. So he devised that at any time t, if uranium atom decays, the beaker will break down and cat will drink the milk. So cat will die. If doesn't decay, cat will remain alive. So paradox is at any given time t, actually as physics tells, cat is both alive and dead both, which is physically not acceptable. But you see, interestingly, mentally it is possible. Means when we don't see the box, in our mind we think that whether cat is alive or dead, both possibilities are there. In your mind this possibility exists, but physically both are not possible. So one of the interesting thing we found in our journey of this physics, that little of spiritual practices combined with foundations of quantum physics helps to comprehend little nicely, little deeply. So here a lot of things related to mind comes. We feel it while going through the studies of it. It helps to understand that this is not really a paradox in a mental world. In physical world, this is a paradox. So how this paradox is resolved? Well, then you need to bring an observer, the person, he opens the box, and once he opens, then then you can see whether cat is alive and dead. So that's how one of the issue of the observer comes into the picture. That's why so many now millions of books are published around the world, observer, consciousness. So that kind of things creep in. Wigner did a lot of work in that area also. Many good scholars also worked. So this is one area where observer or consciousness comes in, because as an observer you can break down that also into wave function, but somebody has to finally decide. Who decides? That's the question. Next. So this is so idea is that if you see from perspective of ancient Indian, our Vedanta, that this de Broglie thing, that wave associated with we have in our scriptures an element called mind, mana. So which has a wave like characteristics. It's not exactly wave, it has a wave like characteristics. Like when me and 2% talk, we say my and your frequency is matching. So our mental setup, we have a wave kind of characteristics which we talk in Vedanta. So I am using the word like, mind like, not exactly mind. So some resemblance is there. So and then observer, the consciousness or the self which we talk in Vedanta comes in. And same experiment, if you blow it up to universe, the supreme observer or supreme self or God, whatever, comes into picture. It's some hint, not the real conclusion or proof, just some hints. Okay, next. So that's how the idea is comes that the role of consciousness comes into picture. Next. So that is the idea that this is Heisenberg at the bottom. After the conversations about Indian philosophy, some of the ideas of quantum physics that had seemed so crazy suddenly made much more sense. So as per this actually the Heisenberg speaks very black and white in the last chapter of his books, especially. And same Schrodinger also, the What is Life or My View of the World, that another book by Schrodinger. They speak very black and white that quantum physics has taught us that at the bottom there is something called consciousness, or that kind of thing comes into picture. Okay, next. This is Huxley. It seems pretty plain that there is a third thing in the universe, to wit, consciousness, which I cannot see to be matter or force or any conceivable modification of either. Next. This is Wigner. Wigner also did a lot of good work in this. There is a book, his name I'll tell you. there are two kinds of reality existence, the existence of my consciousness and the reality existence of everything else. Next. These famous Solvay conferences, during these issues of quantum physics, so much heated debates between them, and all of the founders are sitting here, founders of modern physics, Einstein, Planck, Madame Curie, all of them are there. You cannot read Dirac. So this history is very good. This history, if you see the way they debated, that's a beautiful openness one can learn. Next. So this is Niels Bohr. So Niels Bohr has a book called Light and Life. So this is a wisdom from him that we can admittedly find nothing in physics or chemistry that is even as a remote bearing on consciousness. Yet all of us know that there is such a thing as consciousness because we have it ourselves. So this Bohr, Heisenberg, Schrödinger, Planck and Dirac, these 5-6 of them, actually they were very strong after in 30 years of this 1901 to 1930. In 30 years of this development of physics, they were very they came to a very strong direction about consciousness, which we talked similarly kind of in Vedanta. Next. Yeah, right. So this is Heisenberg. In the end of this book, he writes, after the experience of modern physics, our attitude towards the concepts like mind, soul, life or God will be different from that of 19th century. So after undergoing the developments of quantum physics, he mentions that these concepts which we have been neglecting or putting aside, we will not able to put aside now after what I have learned from quantum physics. It is well, so he says, he goes actually to a big extent. Heisenberg goes to a very, very deeper extent. He says, these concepts touch reality, the fifth line, because they touch reality. Then he goes to next point, not only you cannot neglect them, you will be forced to bring them into modern scientific framework. And then he says, even if bringing these concepts bring contradictions in modern scientific framework, still you have to bring in. And then he gives example like we have infinity in mathematics. When infinity was brought in, so much contradictions were there. Still today we have issues with infinity, but we have absorbed it and we are using it. Similarly, these concepts of soul, God, you can bring it even if you face some difficulties. Next. So this is a little bit brief idea from physics, quantum physics, how the issue of consciousness peeps in. I'll touch upon same issue actually in every discipline comes in. If you go into the foundational issues in most of the disciplines today, same issue of consciousness comes in. Next. Okay, previous one. So just to give you a hint, neuroscience we have issue, philosophy of course, artificial intelligence, psychology, law, even law there is an issue. I don't know, I will show you. Or quantum physics I shared you a little bit, mathematics we had and still we have. Next. So in biology, this is Francis Crick. Now is the time to think about scientifically about consciousness and its relation, if any, to the hypothetical immortal soul. And most important of all, the time to start the experimental study of consciousness in a serious, deliberate way. So in life sciences, we thought that once we have DNA, we have full grip of life. But you know that after DNA, Crick moved to brain. And then he started entering into the study of consciousness. And many scholars felt that we can understand consciousness by using brain. There are many, I'll name a few, but slowly they find that no, it's not possible. Next. Yes, neuroscience, I'll touch next. Like in neuroscience, we have a binding problem. The famous binding problem is if I see an object, I get a lot of inputs from my eyes, from my nose, from my skin when I touch it, right? get a smell. So all these sensory inputs go from nervous system to the brain. But finally, how all these inputs are combined, binded, and I get a one single picture. I don't get a single separate from my nose one input. I don't get a separate, I get a full rose thing complete. So how they get binded inside is called a binding problem, because these problems arise because of lack of mind, concept of mind in modern scientific framework. Okay, next. Similarly, in psychology and neurosciences, conscious experience is a big problem. Means who is who is actually having conscious experience in this body or in life? You can analyze neurons, you can analyze so much, but a conscious experience remains a mystery. Who is experiencing it? And finally, means who is perceiving it? Next. In mathematics, if you go, we had a good work in this area. We have a book of proceedings of that conference, Mathematics and Reality, and many scholars came, especially in Europe. Some countries, a lot of work has been going in this earlier in foundations of mathematics. So famous is Gödel's incompleteness theorem, and of course there are many others, but this comes one of the core aspect in foundations of mathematics. So there the issue comes about mostly the issue comes about the self-reference. So idea is that when I put something, self-reference means I am a liar, for example a sentence. So when you put that in computer, the computer runs in a loop. It cannot handle it, but as a conscious being I can handle it. I know whether I am lying or not. So this self-referencing can be handled by consciousness. Machines or mathematics run into infinity. They cannot handle it. So this issue of consciousness came actually in mathematics in last century. There was a lot of fight between Hilbert and Brouwer. If you see the history of mathematics, foundations of mathematics, beautiful, very nice. We were deliberating on for a couple of years in this area. Many of our institute scholars. So those issues comes out in the foundations, and even they were so strong, like in quantum physics issue remains and you don't develop a separate branch. In mathematics they started, Brouwer developed a separate branch of intuitionism, like separate from formalism. So he developed a quite, and still there is a work going on. There is a parampara, the lineage in Netherlands. We visited some of these professors, scholars there. They still continue that work. Intuitionistic mathematics, they call it intuitionism or intuitionistic mathematics. Basic idea is that I better not go into detail too much. Okay, next. Similarly in AI, this is Rodney. Rodney is one of the famous AI scholar in MIT. So he has a very good paper. If many of you are interested in artificial intelligence, you can read this paper, the relationship between matter and life. Very good. So he analyzes very deeply that robots, whatever beautiful robots we are making and we can make in next 100,000 years, still some very fundamental thing is missing. Some what you call consciousness or self. Specifically that property is missing. So we might be missing something fundamental and currently unimagined in our models of biology. Next. Okay, this is very good wisdom from Schrodinger. This is from his book Nature and the Greeks. Very good book. Small booklet, but very good booklet. So he tells why we are facing all these problems today. Basically, he's summarizing why we are facing so much issues, paradoxes in modern physics. So he says, when you start making a scientific theory, actually you cut out, means you remove yourself from the theory, and that is why later you get into troubles. That is the idea. Means when you start a model, when you want to understand a phenomena, mathematize it, but you remove yourself from the phenomena, and then later you get into paradoxes. So because you started, the beginning step was wrong. That's why he says, I actually do cut out my mind when I construct the real world around me, and I am not aware of this cutting out. And then I am very astonished that the scientific picture of the real world around me is very deficient, because you started with minus mind, minus consciousness, minus soul, and then later you get into the issues. And that is why this probably you cannot read this quote, but it's a very beautiful quote. So I'll read it for you. The scientific world picture vouchsafes a very complete understanding of all that happens. It makes just a little too understandable. Little, he is making a little joke. It allows you to imagine the total display as a mechanical clock, which for all that science knows could just do it without there being consciousness, will, pain, endeavor, delight, anything. Though actually they are existing, but we cut out them. And the reason for this disconnecting situation is just that for the purpose of constructing the picture of the external world, we have used a greatly simplifying device of cutting our own personality out. Hence, removing it. Hence, it is gone and you have a issues. Next. So, briefly tell you about Vedanta, about consciousness, what our ancient Vedanta says. In Vedanta, life has three parts. One is the physical part, the genome or the physical body which we can touch. Then we have a mind, the psychological part, mind, intelligence, false ego, mana, buddhi, ahankar. And then we have self, atma, or our founder gave a word, spiriton, like electron, proton, spiriton. Next. Oh, sorry, previous slide. So this consciousness is a property of spiriton, the atma, self. Next. Next. And then this is the first verse of Vedanta. The purpose of human life is to inquire about God. Athato Brahma Jigyasa. So there is a process given that how our consciousness evolves even in this human life. When we connect to the Supreme, to God, then slowly our consciousness unfolds. If the mind remains focused on matter, it remains confined. When it starts connecting with the Supreme, the consciousness evolves. Next. Next. So I end with this quote, Heisenberg, on the surface of the glass of natural sciences, it may look atheistic, but at the bottom of the glass, God is waiting for you. Next. So these are some of the books. These three books are from our institute. Quantum Physics and Consciousness. This is the book conference we had in Calcutta. Good scholars came and there are many invited articles from around the world. This is the proceedings, Mathematics and Reality. We had in IIT Bhubaneswar, and this is a booklet on consciousness by the founder. Next. And some of these books which I was mentioning you, Physics and Philosophy by Heisenberg. This is Max Planck, Where is Science Going? And then Schrodinger, My View of the World. This is the latest book, recent book. The founders do three books. Next. So I end with this, that in this modern times, our institute works are that neither you can neglect, you will never able to neglect, irrespective of the advancement of science and technology, the ancient wisdom. Neither you can neglect scientific temper, scientific know-how, scientific openness. So what we attempt at a synthesis of the two to move forward in our life's journey. Thank you very much.
Yeah, thank you, Shri Varun Agarwal ji, for your intriguing, magnificent, and excellent presentation. So it is really ignited some sort of thought process in the minds of persons who are very much interested in understanding about the life and many other questions. So now the stage is open for questions. Yeah.
Hello. Hello. I am Professor Anurag Mishra from University of Delhi. And this is very nice compilation of what you have said and what the Western philosophers and physicists have stipulated. But I have one query here, that we intend to, in your talk, we intend to connect what the Western philosophers and physicists have said thoroughly with the Vedantic concepts, isn't it? In Vedanta Upanishads, it is the concept of Brahma or Parabrahma that is very clearly stipulated. So without admitting, without accepting that notion of Brahma and Parabrahma, how can we connect the modern quantum physics or things beyond that with Vedanta? That is my question. Because all these Western physicists, they have never said anything about accepting or rejecting that notion. That is my question.
Very good thought. Well, yes, this like first verse, Athato Brahma Jigyasa. Yes, we will do deal with the Vedanta about Brahman, Parabrahman. True. So, what is that Brahman or Parabrahman? So, to put it simply, in our, as far as my little understanding goes, Brahman is if you want to use both the words Brahman and Parabrahman, then it's like Atma and Paramatma, soul and super soul. If you just want to use one word Brahman, no Parabrahman, so then it can be used for both. Anyway, it doesn't matter. Idea is this, very simply. See, our Vedantic concept is very simple, very simple. Whatever words one want to use. Besides matter, there is a spirit. Very basic foundation. Besides matter, whatever matter that, including this body, including this podium, whatever matter there is, there's a different aspect of reality other than matter too existing. Our Vedantika, that's spirit. Now spirit has two categories, Brahman and Parabrahman, soul and super soul or God. So as far as our modern physics or modern science is concerned, they come to the point of Brahman by not directly, through the issue of consciousness. Consciousness is a property of soul, of Brahman, right? So they come to that point that much, not beyond. From there you get a hint. Well, this itself is a great achievement.
That's perfectly all right. That is achievement. But if we try to connect to Vedantic principles, so we have to accept that thing in totality if we want to connect it. And they start from Parabrahm. So if we reject Parabrahm, like in your, I was very closely watching your slides.
Thank you.
So, I mean, you have gone from matter to psychology to neuroscience to soul only, not beyond that.
Yeah, exactly.
Isn't it?
Exactly.
Not beyond that.
Actually,
so therefore, the concept of consciousness in the present scenario is not connected to Parabrahm. That what I perceive.
Oh, okay. Probably missed one point. Okay. I'll tell. That okay, you go to the Schrödinger cat paradox. Just to give you idea, it's not exact explanation. Before this one. You see in the bottom, there is something called supreme observer. That is Brahman, Parabrahman, which we are talking. Idea is that if you can hit this point, see, consciousness is a very beautiful point to hit. From there, everything will flow. Means, for a seeker of truth, it's not that you get black and white mathematical equational proof, but for a seeker of truth, he will get clear-cut hints. Well, things are there. See, very simple. If soul is there, super soul or God is must. You cannot avoid it. Means if I exist, right? This is a very nice statement by Brouwer, mathematician. If I exist now, which I know I exist, and I don't know how I am here, how I am being put here, I don't know. That means something above me exists. And something above that should also exist to put him there. Finally, there should be some supreme. So, idea is that once you enter the point of consciousness and then to soul, supreme Brahman or Parabrahman will naturally come into picture. That is one side. Not only from there, I have not gone into that side because that is not the focus of presentation today. You can go into the Parabrahman hints from lot of angles from modern physics. For example, very simple point is, you have laws of physics today and they work very nicely in whatever domain they work. We have discovered them, but we have a very big question: from where, how come these laws exist in the universe? From where they have come? We have no answer for that. Every physics has this question. Laws are there, gravitational law, hundreds of laws from childhood we are reading, right? They work well, but from where these laws exist? How come they are there in the universe? There you come to the point, there must be somebody who is above all this, right? So many ways you can come. It's not so difficult.
That is perfect. That is perfect. But do you think that your interpretation converges with the interpretation of Western physicists also?
Western?
Western physicists like Schrodinger, like Heisenberg,
That is what I
like
was
Einstein,
exactly.
whatever they, I mean, actually, we will discuss later.
Means one thing I came to point was Schrodinger and Heisenberg. They come to the completely Indian conclusions in the end of their book. In fact, Schrodinger published a book, and the last chapter of the book, the chapter is Vedanta. And that book was not allowed to be published. Later they found and published. Okay, next.
Yeah, thank you for this
Sorry,
nice
I
response.
took long to answer.
So, any more questions? Queries? Please.
Okay.
Yeah, very nice talk. So my question is, what is the way forward?
What is?
The way forward. So what is the future? So I mean, you told about all the mysteries, and I mean, from my point of view, everything is mystery. What is not mystery in this material world that we cannot think of? So everything is mystery. Only we grasp it by memory, or we match it, whatever we know. If it matches, we accept it, and then we say it's not a mystery. But in reality, if we don't understand each and every aspect related to whatever we are considering, then it's always a mystery. And I mean, when we see it from this point of view, we cannot solve the mysteries over, I mean, many lifetimes, and yugas after yugas will pass, and still the mysteries will remain as it is. So, I mean, from this point of view, what is the way forward? That was the question.
Way forward, well, come to next summer school. That's very easy. Next conferences, next events, next books.
That will be revealed.
Okay.
So
And any question from students? Our students are very silent.
Yeah, they will be joining.
Yeah, okay. And all big brains are speaking big questions, but our students, yeah, okay, please.
So this is the only question I have, that at the beginning, the first slide, actually it was showed that regarding time. So where Professor Das stopped and you have started from that slide, but can we get some glimpse of what the time is actually?
Yeah, means time is a big mystery actually. Our Professor Ram Gopal Upulari from IIT Guwahati, tomorrow he will be giving a presentation there's a session on cosmology, and he has been working on time. The psychological arrow of time, thermodynamics arrow of time, so many arrows of time. So we had an article by him. Time is a big mystery actually. Once you see, if you just close your eyes and little bit meditate, you can put clock in your hand, right? You catch time, but time is still passing. You catch the needle, time is still passing. All of us talk, get born, get old, finish. You come and go, time goes on. You are unable to stop the time. Means whatever you do in this universe, time moves on. You cannot stop it. It goes beyond reach of anybody in this cosmos. Means that's why some portion of time we understand, but not really. If you tomorrow our Upulari will go lot of details into time, so you can have it. It's a open mystery. We are in the flow of time, but we have no idea how this time is sweeping away our life every second. Okay. Yes.
Hello.
Yes.
Nice to meet you, sir. Sir, you talk about free will. Free will is a mystery. So I want to know that I leave my work and I came here to know something here. And you came here to deliver this speech. So is it what's free will, or is it something which make you to come here and give this? What is this free will?
The question is not very clear.
Can you put in a crisp single sentence like?
Okay, in single sentence, what is this free will? Is it what that make you come here and that make all of us to come here to hear you? Or is it something else?
Your first part is very clear, what is free will, but when you connect to the explanation is okay. To put it simply, okay. So I am here, I am equal to 0, right? I am equal to 0. So I have free will to go anywhere. Go here. So this is my free will. This cannot predict where I will be after 2 minutes. I cannot even move. So I have freedom to will and to certain extent, but that action has a limit. I cannot will. I can will to fly, but I cannot fly. You understand? So free will. That's why it's an open mystery. It's still an open question for a normal explorer, scientific explorer. It is an open question. We have no answer. In a spiritual tradition, in our Vedantic tradition, free will is a property of soul, Atma. So like bird has a free will. It can go after 2 seconds here, there, anywhere, right? I can also go here and there. So where there is a life has a free will. Life means there is self there, soul there. So even a paramecium has a free will. Single cell entity. It can go there, here, right? You cannot try. So our freedom to will and act is called free will. Clear?
Yes, good afternoon, sir. So
Okay.
my question is like, there were two lectures today. In one, it was told that we can only regulate our mind, we can't control it. This
What is
was
it?
the first inference in one lecture. And second inference was there are very few people who are pure devotees nowadays. It was told that means we are in material energy of Supreme Lord. So like 1 out of millions people are actually seeing the God. So my actual question now is like how to means why we are not able to control our consciousness, means which is controlling our mind. So is it that consciousness is the supreme energy of Lord, that's why we are not able to control it? That is the question. Means why we are not able to control consciousness? Is it because it is the supreme energy of Lord? Yes, sir.
Okay. Actually, in Western philosophy, these words are very mixed up. Mind, intelligence, consciousness, all these are, when in Vedic thing is a very precise, separate meaning for each thing, first of all. So I take your question as a normal question, like we are not able to control our consciousness or mind. Right? Well, that is why one needs spiritual practice, spiritual guidance. By study, by understanding, by books, by exploration, one can get hints that there is something called mind, but one cannot get a solution to control the mind. You get my point? Through going into philosophy, psychology, neuroscience, even modern physics, you get hints that there is something called mind, but you don't get a solution how to control mind, which is your question. For controlling mind, one needs to undergo spiritual practices. That is one area where science will remain silent. You can maximum give a pill and make the person sleep. That's all. From modern technologies which we have, psychologists, but you cannot make him control the mind. So that is why there is two things. One is the spiritual practices and the spiritual guide. Both are required. These two things helps the person to slowly control the mind. The spiritual guide is the one who has already controlled his mind. He has already understood, realized, practiced the techniques of controlling the mind, not just theory. And the practices he will teach how to do that. So with this, one can do it. Yes, it is possible. It is possible. Okay.
Are there any more questions?
So I hope you have some questions, it seems. Yeah. Any more questions? Okay. So thank you, Shri Varun Agarwal ji, for the nice presentation once again. A big round of applause. Thank you so much. Thank you so much. So,
Thank you, Sri Varun Agarwal ji. Thank you, Dr. Repaka, for engaging us with such an interesting session. Now, without any further ado, I would request Dr. Ramji Repaka to present a memento as a token of appreciation to Sri Varun Agarwal ji. And I would request the audience to join hands to applaud the moment, please. Thank you, sir. So I would request you to please be on the stage. I invite Dr. Debasis Khan, convener, Summer School 2022, to extend our appreciation to Dr. Ramji Repaka in the form of a small memento. So please. Thank you, sir.
Thank you, Manas. Now I'll take over from Manas. Okay, so we are moving on. Time is a mystery. Time moves on, right? It's a mystery that in spite of having such two big sessions and all the interactions, still we are well within time. So time is still a mystery. Okay, so let's move on. We are moving to the next program, that is Young Minds Speak Again, once again. We are more interested in more young minds speaking. So this time, the speaker is going to be Mr. Rajesh Pandit, alumnus of IISER, Kolkata, India, IISER, what we call it as, and he is going to speak on the limits of mathematical logic. So this will be an online session. Over to you, Mr. Rajesh Pandit. While we get Mr. Rajesh Pandit online, I have some announcements to be made. After this session, we will all proceed for our tour and sightseeing, but today's tour is going to be, we are going to go and visit Lord Jagannath, take his darshan, okay, and we'll have our dinner also at the temple. So we would like you all to stay with us, and let us all go and take the blessings of Lord Jagannath and come back. Are we ready? So if you all have any questions for any specific speakers, you can write down the questions, put your name and pass it on to us. We'll reach it out to the speakers and we'll try to get the answers also for you. Thank you very much.
Hello. Thank you very much for this opportunity. Now I will present the limit of mathematical logic. So please move to the next page. So the overview of my presentation will be historical development of mathematics, fundamental aspects of mathematics, mathematical logic, and limit of mathematical logic. So let's start with historical development of mathematics first. Please move to the next page. Mathematics is a whole huge and wonderfully diverse subject. It deals with so many amazing stuffs. Those stuffs at the very beginning start with counting. In fact, counting is not just human traits, animal count as well. And evidence of human counting goes back to prehistoric time around 50,000 BC. With marks made on bones, there were several inventions over the years. Egyptian having the first equation, ancient Greek developed geometry and numerology. Negative number were invented in China and zero in India. Then algebra were developed. There are a lot more in the history of mathematics, but I am moving to the modern age of mathematics. Modern mathematics can be broadly broken into two areas, that is pure mathematics and applied mathematics. Mathematics help us to solve the real world problem. Please go to the next. Now we are more interested in fundamental of mathematics. Foundation of mathematics is the properties of mathematics itself, and ask what are the basics and all the rules of mathematics is. Is there complete set of fundamental rules called axioms from which all the mathematics come from? Can we prove that all consistent in itself? Mathematical logic, set theory, category theory try to answer this, and famous results in set theory is Gödel's incompleteness theorem, which for most people means that mathematics does not have a complete set of axioms. Mathematics explains so much stuff in the universe so well. We have also theory of computation, which looks at different models of computing and efficiently they solve problems. It contains complexity theory, which look at what is and what is not computable, and how much memory and time you need. So that is fundamental aspects of mathematics. Please move to the next page. So we will move to the mathematical logic. Mathematical logic is the study of formal logic within mathematics. Mathematical logic commonly addresses the mathematical properties of formal systems of logic, such as their expressive and deductive power. The mathematical logic helps us to unfold the universal truth through mathematical deduction. The logic is the most basic language of the mathematics and the underlying principle of proof. So an important question came in: how do we formulate the logic we have been using in our proof? For that, please move to the next page. For that, let's look at propositional logic. A proposition is a statement that is by itself either true or false. Say, for example, grass is green and 2 plus 2 is equals to 5. Here, grass is green, the first statement is true, and the second statement is false. So the propositional logic is a mathematical system for reasoning about proposition and how they relate to one another. Propositional logic enables us to formally encode how the truth of various propositions influences the truth of other propositions. It determines if certain combinations of propositions are always, sometimes, or never true. It determines whether certain combination of propositions logically entails other combinations. Please move to the next page. Now we are interested in today's topic, that is limit of mathematical logic. So here logic is formal discipline of creating and validating reason. The value of logic lies in its correctness. That is to say that formal logic can be shown to be correct given basic assumptions about existence and knowledge. As such, it is widely used to prove theories, solve problems, and make decisions. In some cases, it used to fully automate decision. If logic's strength is its correctness, its limitations are related to its range. In many cases, same systems of logic don't handle types of thought that human can process with ease. Now we'll present some examples where this logic does not work. So first example is the partial truth. Many forms of logic can handle true or false, where rational thought can easily see a glass as approximately half full. Logic tends to give you false that glass is full and false that is empty. It should be noted that some form of logic, including fuzzy logic, can handle partial truth. Now we will see the next example, that is language. Each form of logic represents observations in formal language of logic. This language imposes limitation that don't exist in natural language. In other words, language can't represent or consider the subtleties of natural language, such as French. Now we'll move to the next example, that is uncertainty. Some forms of logic fail to handle uncertainty. Although this is studied by a field known as probabilistic logic, any form of logic that can't handle uncertainty has difficulty with real-world decision making because uncertainty is common. Now we'll move to the human perception. Using logic to create something that people are passionate about, such as architecture, tends to have low value. It is notoriously difficult to codify perceptions such as aesthetics, emotion, or cultural concept. For example, if you were to write a movie review with formal logic, humans would typically view the results as lacking insight. Artificial intelligence could review a film by looking at people's opinion about similar films and assimilating them. Such approach are the effect of judgment that can generally be viewed as low value. So if you are a mathematician, this should ring alarms bell that the law of excluded middle is pretty essential for mathematics. As Hilbert, a truly great mathematician, put it, to take the law of excluded middle away from mathematician would be like denying the astronomer the telescope or the boxer the use of his fists. In mathematics, we deal with such abstract statement. It is easier to prove that if something were not true, we have a contradiction, than to actually construct the thing in question. Now there are unanswered questions that cannot be answered using the logic. So these are that this may provide a satisfactory answer to mathematics as it is used, but what about human curiosity? After all, there are statements within mathematics which relate to proofs within mathematics and seem defined by this rather than given meaning through applications. The biggest problem in the set theory and measure theory comes from the creation of set so wild and crazy that it's hard to see any resemblance to the real world. But in what sense can a set, intuitively a collection of objects, be disconnected from our understanding of the real world? That is the place where object seems to exist. Would a blind, deaf, mute person who had lost their smell and their taste, their touch, so just a mind without external input, be able to conceive the objects? There are so many things to that is not answered by the mathematical logic. So the dilemma remains for the most abstract part of mathematics. Please go to the next page. So these are the references from where I have taken the content. So there are a lot more to talk about the limits of mathematical logic. But with that, I will stop here. Thank you.
Thank you, Rajesh, for that wonderful talk on the limits of mathematical logic. Now, if the audience have any questions to Rajesh, then we can have it. Online, any questions are there? Any questions? Okay, Rajesh, there is a question on the chat box. You can read it and you can answer the question. How can we know that someone has now controlled his mind completely? What are the set of rules that we can apply so that we know that this guy or someone has controlled his mind completely? He is no more under the control of his mind.
Sorry,
Would
I
you like
didn't
to?
get.
Yeah.
Sorry, I
Can
didn't
you
get
switch
the
on your
question.
video, please?
Please, I
Yeah.
request host, please allow me to on the stop. You have stopped my videos. Please allow it. I request host to please open my video. They unmute and mute. I so. Yeah, now it is okay. So can you please read once again the question?
It's there on the chat box.
Okay, sure. Let me see.
It is a question to the earlier speaker. No questions. Okay, that was a mistake, and that question was for the earlier speaker.
Okay, thank you.
So, if the audience have any questions to the speaker, we'll take it. Otherwise, we'll move on to the next program. Yes. You want to come here, or you want to give the mic?
Yes, good afternoon, sir. Am I
Good
audible?
afternoon. Yes, you are.
Yes, sir. So my
Thank you.
question is like you told that value of logic lies in its correctness, but like in this correctness, like how we are deciding it is correct or not, like on what frame of reference we are telling it is correctness. If we are saying that our logic is correct, means in what
Yes, yes.
context we are
I got your question. So the thing is that for the mathematics, we have the set of axioms, and based on that, we decide that whether a sentence is correct or not. So using that logical frame, we decide. Is that help?
No, sir, like, but in finding if it is correct or not, what is the frame of reference? Like, what is in what context we are telling it is correct or it is wrong? Yes.
So for that, we have already defined the set of axioms. Based on that, that are the properties of mathematics that comes under the foundation of mathematics, and that tells us whether a given sentence or a statement is correct or not. As I defined the proposition, that proposition is a statement that is by itself, either it is true or false. So these sort of propositions are used to identify, or they give the meaning to the correctness of the sentences or statements.
Yes, sir. Thank you, sir. Got it. Thank you.
Okay, thank
Thank
you,
you.
Niket, for that question and for the answer. And we thank Mr. Rajesh Pandit for this wonderful presentation. Let's give him a
Thank you,
big
sir.
round of applause.
Thank you so much.
So we are always excited about the young mind speaking. So if one of your all, anybody is interested, you can approach us. We can become part of one of our speakers in our next conference. Okay, thank you very much. And
Thank
now you are going to be free now. Okay. So before that, we want to have a photographic session. I would request Jitendal, before we disperse, we'll have a photographic session, and after that we'll proceed. Transport will be arranged for all of us to move to the temple, and we'll have darshan, we'll have dinner there, and some activities which you will witness there. So thank you, Rajesh, for your wonderful presentation. Thank you.
sir. Thank you. Thank you
Thank you.
so much.
Yeah, thank you. Yeah. So all of you can come forward for the photographic session, group photo. कैमरामैन आप सजेस्ट कीजिए कैसा फोटो लेना है ग्रुप फोटो Upar. Okay. The photographer is suggesting on top. So please come this way. Please come this way. Please come this way. There you have to struggle. Come this way. Come this way. Sorry, the taller ones at the back. We can make, if possible, 2 rows or 3 rows. The third row will be sitting down.
Some of us can stand below, so can we please come little ahead so that one row can stand below? नीचे खड़े हो जाइए, 3 आ जाएंगे आराम से, एक यहाँ पे बैठ जाइए kneeling position पे, पीछे खड़े रहेंगे. Excuse me, you can stand there. Please come. Bye sir.
Cameraman, photographer, आप बताइए, please you. Some of them are hidden. Okay, you can go up. Come. Ready. Thank you. Thank you. Okay, the Soya University will go by their own transport to the temple. Others will wait for the transport. We will go together to the temple. So thank you all for coming today and attending the sessions. We would request all of you to come tomorrow also and grace the occasions in the same way. You will have more interesting topics tomorrow. Yeah, and as usual, we'll have a nice breakfast in the morning. So please come early, have a breakfast and come and assemble in the hall. Thank you very much.
नीलाद्री में जाना है अभी सबको, जहाँ जहाँ जिनका एकोमोडेशन बैग रखना है वहीं पे, लैपटॉप बैग वहीं पे रख के फिर वहाँ से पैदल आना है वहाँ पे जगन्नाथ।
हाँ, लेकिन अभी तो व्हीकल तो हम लोग लेके जा रहे हैं ना।
व्हीकल लेके जा रहे हैं, बट अजय उनको एक बार जैसे बोलना है कि अपना बैग रखना है वहाँ पे, बैग वहाँ पे नहीं ले जा सकते, व्हीकल से डायरेक्ट मंदिर नहीं जा रहे हैं।
There is an announcement for all of you. 1 minute. There is an announcement. We are all going to the respective hotels or accommodation wherever it is provided. You can leave your bags and everything and proceed to the temple. Okay. Thank you very much. Thank you. बाहर का डिसाइड कर लेंगे आप।
ये जो बच्चे हैं जो जा रहे हैं वहाँ पे, अफरोज प्रभु सोया यूनिवर्सिटी तो वो चला जाएगा। अफरोज प्रभु जो अफरोज प्रभु ने बोला था कि उधर अंदर में वो फिर मैं जाऊँगा इनके साथ स्टूडेंट के साथ, तो नीलाद्री में जाएंगे उन पर, तो हम या तो ग्रैंड ग्रैंड
वहाँ चल के भी जा सकते हैं। नीलाद्री में छोड़ देंगे, बट अनाउंस कुछ तो क्लियर अनाउंसमेंट करना पड़ेगा। हम बाहर कर देंगे।